Here we're going to solve some more complicated integrals using the technique of integration by parts. Integration by parts comes from doing the product rule in reverse. We're familiar with the product rule, that the derivative of uv equals u times the derivative of v plus v times the derivative of u. We could get rid of the dx part. And then integrate all terms. And we'll get this. How does this help us solve an integral such as xe to the x dx? Well, you may notice that xe to the x dx is a product of two functions. It is in the form of u times dv, where the u part is the x, and the dv part is e to the x dx. So that's the idea, is we're going to take a complicated integrand and split it up into two parts, u and dv. Now we get to choose which part of the integrand gets to be u and which part should be dv. For now, I know from experience that these would be the best choice just for this problem, so let's let u equal x, and then dv will be represented by e to the x dx. Now, the idea behind integration by parts is that if we were to rearrange this formula and solve it for the integral of u dv, we'd be left with this, which at first seems like kind of complicated and seems like a lot. But what we'll do is we'll find a way to solve an integral that we couldn't solve in the form that it's in currently. All we need is a couple other things to fill out the rest of the formula. Like for example, we've got u now. We said that it was going to be x. But we still don't know what v is. And we don't know what du is. So we actually have a few things to figure out before we can finally solve this. But if we are able to solve this part of it, then we'll have an answer for our antiderivative. Du would come from finding a derivative of u. So that'll be 1 dx. And now we can place that in its proper place. The antiderivative of e to the x dx, if we integrate e to the x, we get e to the x. We don't have to put the plus c for this formula. It'll come in later. Now we can put an e to the x here in place of v. And we can also put an e to the x here. Now we have our integral set up. And hopefully it'll be an easier integral to do than the original. And look at that, it is. So the antiderivative here would just be e to the x plus c. That's where we get the plus c, is by integrating that last part. And this is going to be our final answer. Let's try the next one, which takes just a little bit more work. We have to pick a u and a dv. I'm going to choose u to be x squared, and dv can again be e to the x dx. The great thing about that choice is that it's easy to find an antiderivative of e to the x. Some expressions it's hard to find an antiderivative for. Now let's do the derivative here. We'll get 2x dx and e to the x. That's all we need in order to fill in the formula. So let's fill it in. We need a u and a v and an integral of v du. So just to remind ourselves, it's u v v du. Okay, so u is going to be x squared. V is e to the x. So far, so good. We have to put an e to the x here. And now we have to put 2x dx there. Now, as we can see, it's a little bit tougher. That's not a super easy integral to find, e to the x times 2x dx. In fact, it looks quite a bit like the one we had done above, right? So what we're going to have to do is we're going to have to do integration by parts yet again for a second time. And sometimes, if you do integration by parts a couple times, you can finally solve the problem. So since I already used the letters u and v, I'll come up with some new ones. How about a and b? Let a equal something, and let db equal something. Then dA will be needed. We'll also need B. Rewrite the whole thing. And what we're going to put in the place of that integral above will be the formula a times b minus integral of b dA. So, let's let a be 2x, and dB can be e to the x dx. That would make dA 2 dx, and b is e to the x. Replace a with 2x. B is e to the x. And b is e to the x, and dA is 2 dx. It looks like we've almost got it. There's just one more step. And that is to compute this antiderivative here. All right. Final answer, x squared e to the x minus 2x e to the x plus 2e to the x plus c.